All right, sixth graders, we're going to be working on our homework today. Let's go ahead and do 13 through 18, use the order of operations to evaluate. In number 13, we see that we have an expression here. We notice the middle part is missing in this next one, so we know we're going to be combining like terms. We're following PEMDAS, doing parentheses first. 3.1 plus 6.4 is going to give us 9.5. So we're going to write that in, 9.5. Next, we see that 4.5 is here, so we know that we're subtracting two numbers. Since we already had 9.5 here, we can assume that remains. And our next part in PEMDAS is exponents, so we can assume that 4 to the second power goes here. 4 to the second power is 4 times 4. And that's 16. All right, 4.5 is down here again, which means we're doing the subtraction part first. We don't have any multiplication here, so addition and subtraction is done in order from left to right. 16 minus 9.5 is going to give us, let's find out, 16 minus 9.5. Notice I'm lining up my decimal. That gives me a 5 here. I know I had to borrow one. And 15 minus 9 is 6. So this would be 6.5. Now we have 6.5 plus 4.5, and that's going to give us 11. Next, I have number 15 to do, so let's go ahead and work here. We see that all the other terms inside of this expression remain except for the 3 to the second power. So that tells us that we're working the exponent inside of the parentheses first. 3 to the second power is 3 times 3. And that's 9. Now we have to work the parentheses. 9 plus 6. That's going to give us 15. And now the next thing in PEMDAS is multiplication. So even though we have this operation first, we have to work this one first because in PEMDAS we have to follow the steps. 15 times 3 is 45. And now we're taking 157.8 and minusing 45 from it. That'll give us 112.8. All right, let's move on. Let's see, number 17 is mine to do. You'll have 16 and 18, so let's try this. First, I have to follow PEMDAS again. I see that I have a parentheses with exponents over here. So this is 1/2 to the third power. Remember, 1/2 to the third power means 1/2 to the power of 3 on my numerator and my denominator. So this is going to equal 1/8. I can rewrite this to show that I have 1.25 I'm multiplying that to 4. I'm adding it to 3. I'm multiplying it to 2. And I'm dividing it by 1/8. Whew, that's a mouthful. All right, remember we have to do our multiplication and division first. So let's see, working left to right, what we got. We've got 1.25 times 4, all right, and that's going to give us 5. we're going to be adding this later to 3 times 2, which is 6, divided by 1/8. Now, what is 6 divided by 1/8? Well, I would have to say this is like a fraction, 6 divided by 1/8. And if we have a fraction in a fraction, we know we have to use KCF. So we'll keep the first term the same, and we'll multiply by flipping the second one, all right? We keep, we change, and we flip. And this is going to give us 48. So now we have 5 plus 48. Five plus 48, well, that's going to give us 53. All right, next I got to do number 20. It says insert grouping symbol so that the expression has the given value. Well, if I took this and I did it exactly like it states, I would have 1/3 of 21, okay? Because 1/3 times 21 is multiplying 21 to 1 and then dividing it by 3, and that would end up being 7. That would be 7 minus 3. But 7 minus 3 equals 4. And we see that that is not the value of 6. So how would I change this? By putting a grouping symbol here. Well, I could put parentheses around here. And now I'd have 21 minus 3. And 21 minus 3 would be 18. By having to do the parentheses first, before I multiply to this fraction, it enables me to change the number that I'm multiplying to my numerator. 18 times 1 is 18, and 18 divided by 3, well, that fraction is a division problem. 18 divided by 3 equals 6. And as you can see, by arranging my grouping symbol in the right place, I can get a different value. Number 20, let's see, I'm sorry, I should have done 19 and 21. I'm going to leave that one for you guys to do, and then I'm going to go ahead and take care of, well, I'll tell you what, I was supposed to do 2 of these, so I will go ahead and take care of number 21 as well. All right, how can I get a target value of 43? Right now, if I take 2.5 and add it to 5, well, first I would have to multiply these two together, right? That's what PEMDAS says, and this would be 30. And if I took 2.5, I added it to 30, and minus 2, would I get 43? Let's see. This would be 32.5 minus 2, and as you can see, I'm not going to get 30. This is going to give me 30.5. So what can I do to get my target value at 43? Well, I know that I want a number to be, let's see, I need my number to be divided by, or excuse me, a bigger number to get multiplied to 6 in order to get a bigger value. So let's try first putting these parentheses around this first. And if I did, that would give me 7.5 that I'm multiplying to 6. And then subtracting 2. All right? And if I did 7.5 times 6, Well, let's see, 7.5 times 6. Now that's going to give me 30. That's 42, 43, 44, 45. I move my decimal over 1, so I move it back. Oh, sorry about that. I move this back, and that'll give me 45. Look at that. Now I have 45 minus 2, and that will equal 43. And that was my target value. And everybody see by just putting that parentheses there, it made all the difference. All right, I caught up with you guys. I left you number 19 to do instead of number 21. So that means it puts me back on my odd numbers. So I should be doing number 23. Write a numerical expression with at least 3 operations that has the same value as the following expression, and then justify your answer. So we're going to write a numerical expression with at least 3 operations that has the same value as this. I need 3 operations to solve it. Well, in order to do this next one, I have to know what the value is. So I'm going to find out what it is first. I do parentheses first. 8 minus 4 is 4. 4 divided by 2. Remember, division comes before addition. 4 divided by 2 is 2. And now I have 5 plus 2 plus 3. That's going to equal 10. So I need 3 expressions, right, with at least 3 operations that have the same value as 10. All right. So let's try this one. I can say, let's see, 3 operations. I can say that, well, 8 times 2, that's 1 operation. That would give me 16. And I can say 8 times 2 minus, and in this parentheses, I can put, well, I would need it to equal 6, right, to get the value of 10. So I can say, see, we can go with 16. Well, if I want 6, I could go with 36 divided by 6. Oops. I have 3 operations. I have my parentheses, which is division, right? I also have multiplication. I have subtraction. I have to do my division first because it's in parentheses, and I'll do my multiplication, then I would subtract 3 operations. I could even alter this a little to say I have 8 times 2, and I could say minus, and what if this time I was to put 6 to the 2nd power, and then say I'm going to divide it by 6. Plus 6 to the 2nd power is another way of saying 36, because 6 to the 2nd power is 6 times 6. And then 6 divided by 6 would give me 6. And then I would subtract that from 16 to get 10. Okay, another way I could put this is if I needed to get 16 here, I could get, let's see, 16. But what if instead I took 32 and divided it by 2? That would give me 16. And I could subtract that from, well, again, I could put 6 to the 2nd power divided by 6. Now I have 3 operations, right, with or 3 expressions with at least 3 operations that will give me the same value. All right, and that value is 10. All right, I'm on number 25. Evan says that the value of a number our numerical expression, 0.2 to the second power plus 12 divided by 1.5 times 4 is 32.04. Do we agree? Well, we're going to have to solve this, obviously. So 0.2 to the second power plus 12 divided by 1.5 times 4. Well, we have to do parentheses first, so 1.5 times 4, that's like 15 times 4, which would give us 60. So with the decimal there, this is going to be 6. And I'm going to bring everything else down. The next thing I'm supposed to do is exponents. So I have 0.2 to the second power. I know 0.2 times 0.2 is going to give me 0.04. And for those that didn't follow along, watch 0.2 times 0.2. We know 2 times 2 is 4. But remember, we have 1, 2 places for our decimals now. 1, 2. So it's going to be 0.04. We'll be adding that to 12, dividing it by 6. We have to do division first. 12 divided by 6 is 2, so that's going to be 0.04 plus 2. And that's going to give me 2.04. So do I agree? No, I do not agree with Evan's statement. I wonder what Evan did wrong. I'm thinking, just off the top of my head, that he looks like he took 12 and divided 1.5 and then multiplied it to 4. He did not do his parentheses first, and that cost him. Okay? As you can see, if we would have took 12 and divided by 1.5, that would have given us a different value to multiply to 4. Let's just check that out in the calculator. I'm just curious if I'm getting this right here. If I would have took 12 and multiplied it to 1.5, that would have gave me 18. And then if I multiply that to 4, that gave me 72. And now if I added that, let's see here, I had, I was saying 32. Maybe this isn't what happened. Divided it by 1. Wait a minute, I think I did something wrong here. It's 12, I said divided by 1.5. Gave me 8. And then if I multiplied it to 4, that gave me 32. Now if I added it to 0.2 to the second power, and we know that's 0.04, I would get 32.4. So that's exactly what he did. So under explain, I think I would put Evan forgot to do what was in the parentheses first. Okay, let's go to number 27. I think that's my last one. Oh, maybe not. Higher order thinking question. Frederick evaluates the numerical expression that he has here and records the answer 51.5. Lana evaluates the numerical expression and records the answer as 59.1. The expressions have the same numbers and operations. This is true. I see all the same numbers in here. Explain how Frederick and Lana can both be correct. They can be correct because when you put these brackets and parentheses in places, you have to go ahead and perform those operations first. That's pretty easy. Because the parentheses and brackets in Frederick's expression will create a different value. Okay? All right. And I guess you could put because you have to follow your order of operation. All right, let's go on to the next one. Frederick, sorry about that. There we go. All right, and number 29. In an ecosystem, some animals get energy by eating plants. Write and evaluate an expression to find how many pounds of plants an herd of 10 elk can eat in 1 week. Wow. Okay. It says an elk can eat 20 pounds of plants each day. So we're wanting to know how many pounds of plants a herd of 10 elk can eat in 1 week. Okay. All right. Well, the first thing we need to do is how much can one elk eat in 1 week? And since he can eat 20 pounds each day, we know that that's going to be 20 times 7. If there's 18 elk, we know after we found that answer, we're going to be multiplying our answer by 18. So let's see, 20 times 7, well, 2 times 7 is 14, so 20 times 7 is 140. Well, now we have 140 times 18. Well, that's going to give us 0. That'll give us 32. That's 8, 9, 10, 11. And then we have 140 that's going to go here because anything multiplied to 1 is itself. And we have to remember to add that 0. We have a 0, 2, 5, and a 2. That tells me it's 2,520. And since we're talking about pounds of food, that's pounds of plants per day. Pounds per day. Okay? All right. Well, I did all mine. You guys have yours to do. See you in class for grading. Have a great night. Great night.